Ever wanted to know what would happen if you fell into a black hole? The answer is not what you might expect. In the center of our galaxy, there is an invisible giant, a cosmic devourer with a mass 4 million times that of our sun, quietly waiting. Black holes are not just science fiction. They're the most extreme objects in the universe. In this video, we'll talk all about black holes and even see what happens when these beasts collide.
The 411 on black holes.
They don't emit light, they don't play by the rules, and they do not care about your feelings.
Black holes are the bouncers of the universe, massive, silent, and absolutely done with your Newtonian nonsense. They warp space, they stretch time, and if you get too close, you are not coming back. Not even light makes it out alive. These aren't just astrophysical curiosities. Black holes are engines of cosmic chaos, lurking in galactic hearts and hurling jets of radiation halfway across the universe. Some are the remnants of dead stars. Others are so colossal and so ancient, scientists are still arguing over how they even formed in the first place. What is a black hole really?
If the universe were a video game, black holes would be the unpatched glitch that devours everything on screen. They aren't solid objects. You can't physically touch a black hole or lasso it in like a runaway horse.
They are regions of space so absurdly dense that gravity itself collapses inward. Once something crosses the event horizon of this region, the event horizon being the invisible edge of no return, it's over. Light, matter, space, time, all your hopes and dreams, all toast.
It's the same thing with a black hole. It's fine now being 1,500 light years away, but if it somehow starts growing, yikes.
Unfortunately, there is a black hole fairly close to Earth. The nearest death trap to our planet is a cozy 1,560 light years away. It's called Gaia BH1, and while it poses no immediate threat, it's like living 6 doors down from a guy with a pack of drooling hyenas. You're safe for now, behind the walls of your house. But if those hyenas ever get out and find their way into your yard, oof. To give you an idea of how big black holes can be, I'll introduce you to another one in our galactic backyard. This one is called Sagittarius A with an asterisk, because apparently that's how black holes are named. This is a supermassive black hole, meaning it's like a normal one, but way bigger. It is right at the center of our galaxy, like a spider's web in the middle of your living room. And it is huge. Its mass is about 4 million suns, and it's located roughly 26,000 light years away from us, at the center of the Milky Way.
And the worst part is that you can't even see it. Why? Because black holes don't emit light. Scientists can only see their tantrums, like when they gobble up gas and scream with X-rays, or when they hurl jets of particles at near light speed like they're trying to win a cosmic punk rock contest.
How black holes are born.
According to Yale astrophysicist Priyamvada Natarajan, hope I said that right, black holes form in 2 main flavors. First, you've got stellar black holes.
These are born the classic way. A massive star burns through its nuclear fuel, shrugs, and collapses under its own weight. If it started out with more than 8 or 10 times the mass of our sun, the star goes out with a bang, an explosive death that leaves behind a gravitational nightmare. In even simpler terms, when a big star dies because it runs out of gas, it can no longer support itself and collapses. But because the star is so big, with so much mass, the collapse creates a gravitational anomaly known as a black hole. Next up are direct collapse black holes. These black holes have nothing to do with stars. In the early universe, immense clouds of gas are believed to have just collapsed directly into black holes, skipping the whole burn bright, die young routine and going straight to cosmic horror.
Some of these early monsters may have been thousands or even hundreds of thousands of solar masses. They are the likely ancestors of these supermassive black holes that now haunt galactic centers like sleepy but deadly landlords. Stellar black hole or direct collapse black hole, they both do the same thing. They eat, and both of them are at the center of a lot of math drama. You can't talk about black holes without getting a little mathematical.
Einstein was right. The math behind black holes fell out of Einstein's introduction of general relativity in 1915, but even Einstein thought the idea was a bit much. He came up with the math to explain black holes and couldn't even believe such things existed. But the math doesn't lie. It was proved by Carl Schwarzschild, who took Einstein's equations and came back with confirmation that out in the universe, giant wells of dense gravity were swallowing entire solar systems, like some evil space monster.
At first, scientists weren't sure if these mathematical nightmares were physically real, but when astronomers started detecting neutron stars, the collapsed cores of dead stars, it became obvious. Because if nature could make neutron stars, black holes were then totally on the table.
And then came Cygnus X1, the first confirmed black hole in human history. Scientists spotted X-rays screaming from a bright blue star being slowly devoured by an invisible companion. Stephen Hawking famously bet it wasn't a black hole. He lost that bet because it was, and still is, a black hole. It is huge. Cygnus X1 is about 7,000 light-years from Earth in the constellation Cygnus. Its main star is a supergiant revolving around an invisible friend every 5.6 days. That invisible friend was only identified because of its X-ray emissions, which are understood to be matter torn from the supergiant host star that's slowly but surely being devoured.
Scary stuff, right? But what happens when the food runs out? Do black holes live forever, or
do black holes die?
Actually, black holes do die. It's just that it happens very, very, very slowly.
Through a process called Hawking radiation, black holes are thought to gradually leak particles over time. This involves quantum shenanigans, a real term that describes virtual particles popping into existence near the event horizon. Normally, they annihilate each other immediately, but near a black hole, one particle can fall in while the other escapes. Over unimaginable time frames, that trickle could evaporate the black hole, sort of like a pinhole in a pool might drain the pool after a while. Only in the case of a black hole, scientists think it would take even longer than the universe has already been in existence.
So to bleed a black hole dry, you would need more than 5 billion years. And you thought watching grass grow was slow.
Wormholes and the wall of fire.
When you fall into a black hole, it's a pretty terrible experience. I'm going to take you through it step by step later, but I wanted to bring it up now because of a study that came out a little while ago. This study suggested that the event horizon might be a wall of fire. Not metaphorical fire, actual fire.
You already know that a black hole is not a physical thing, but a part of space where gravity is so strong it can tear apart existence itself. As true as that all is, scientists still have no clue what is actually inside of a black hole. Some think that if you fall in, you'll stretch out like a piece of spaghetti for the next few billion years. Spaghettification. Others think the quantum effects of the black hole mean that you get incinerated the instant you cross the threshold because the entrance is actual quantum fire.
Which sounds worse to you, becoming a noodle or being flash fried?
The third option is that black holes act as wormholes. Many scientists have speculated over the years that black holes are teleporters, stargates, or time machines. The theory is that at the center of a black hole is a singularity, and that singularity could connect to a white hole, the opposite of a black hole, somewhere else in the universe.
Thus, a wormhole. But since nobody's ever sent a probe into a black hole, there's currently no way of knowing. To be honest, 2,000 years from now, humanity could live across 24 worlds, and we still might not know what's in a black hole.
What do black holes look like?
Nobody knew what a black hole looked like until 2019, when the Event Horizon Telescope gave us the first real image of one, and it was amazing.
Here it is in all its orange glory. You are looking at the center of the M87 galaxy, 55 million light-years away from Earth. The image looks like an orange donut, almost like a black hole glamour shot. What you're really seeing is the black hole outlined by emissions from all of the hot gas swirling around it, attracted to the gravity near its event horizon.
This is where I need to give a little anatomy lesson, starting with the black hole's singularity.
At the very heart of the black hole is all the matter that collapsed. It's stuck in an infinite density known as a singularity. What's actually happening within a singularity is one of the greatest mysteries of science. Nobody has any idea, but it probably has something to do with quantum mechanics. The singularity is the hole itself, the core of the black hole. Around it is the event horizon, the radius from which matter and energy can't escape. The event horizon is the point of no return. This is the black part of the black hole.
You can see the event horizon in the image I showed you. It's the little black dot in the center of the orange ring.
The innermost part of the orange ring is the photon sphere. Photons are emitted from hot plasma in accretion disks that bend around the event horizon, creating a bright ring around the dark center. But that's only part of the ring. The rest is known as the accretion disk. It's the outermost edge consisting of superheated gas and dust swirling at blistering speeds. The accretion disk creates electromagnetic radiation, which is what shows up in Earth's satellites.
The accretion disk is the bulk of that brightly glowing orange ring. Without it, the black hole would be invisible.
In other black holes, you can often see the relativistic jets too. These are from when a black hole is feeding on something, like a star or dust. The meal, if you could call it that, produces particles and radiation.
It's like when you're eating a pulled pork sandwich and the pork keeps falling out and you have to wear a bib and your date laughs at you and the whole thing is a total disaster.
Only in this case, the debris from the black hole's meal blasts out of it at almost light speed and extends like a flamethrower for thousands of light years into space.
Cool, right? Science is just getting started with black holes. The first image ever was only captured 6 years ago. And then in 2022, scientists revealed an image of Sagittarius A asterisk. And here it is, courtesy of NASA. It's a little fuzzier and a little quieter, probably because it has nothing around it left to consume. It's running on fumes.
How many black holes are there?
Estimates suggest the Milky Way is crawling with black holes, but because they are invisible, scientists have a hard time finding them. When it comes to the whole universe, it's been estimated that anywhere from 10 million to a billion stellar black holes are quietly lurking between the stars.
1 in every 1,000 stars might die with enough energy to become a black hole. That's like if 1 in 1,000 people turn into a gargoyle or a vampire. It might not seem like a lot, but suddenly there would be gargoyles in every corner. The most common type of black holes are the stellar black holes. Like I said before, they form when very big stars go supernova. What I neglected to mention is that stellar black holes aren't that big. They're typically only a few times more massive than the sun, but they fit into an area the size of Chicago. That's the thing about the singularity inside the black hole. It's got all the density of something 100,000 times bigger than Earth, but it's compacted into something the size of the city.
Even scarier are these supermassive black holes, typically found only in the centers of galaxies. They are billions of times heavier than most stars, and nobody knows where they came from.
They're almost like squatters that refuse to leave. Each galaxy seems to have a resident supermassive black hole, and no one knows how old they are, why they're at the center of solar systems, or what they even do. They're just huge, aimless, very hungry black holes.
Try not to look one in the eye. You'll regret it.
Thoughts from the event horizon.
People like to think of black holes as cosmic vacuum cleaners, sucking everything into their holes of doom, but that's not entirely accurate. Black holes are more like the edge of scientific understanding.
Black holes mark the edge of physics. They're the one place where science stops making sense. Gravity starts breaking rules, and quantum mechanics gets heavily invested.
These enigmas shape galaxies, warp time, and probably hold the secrets to alternate realities. We haven't been inside one, but we have taken a photo of one. At least scientists are getting closer to understanding the weirdest, darkest, most beautiful mysteries the universe has to offer. Just don't get too close. And before we get into the first monsters of the universe colliding, I wanted to give a big thank you to Montana G Mama for the super thanks. It really means a lot, and we wouldn't be here without you. Be sure to subscribe and let me know what other space objects you'd like to hear about next.
The origins of black holes.
The very first black holes in the universe may have exploded into existence around the same time that the first stars were born.
Astrophysicist Jonathan Tan from the University of Virginia thinks he knows how supermassive black holes came to be. Remember that normal stellar black holes are born from the death of a star, but supermassive ones, the ones that lurk at the center of galaxies, even our own, are a mystery. Now Tan thinks he's solved it. Supermassive black holes may have been created through dark matter, ancient starlight, and a whole lot of hydrogen getting obliterated. He's calling his new theory the Pop 3.1 model.
To understand it, I have to rewind to the dawn of time.
The first monsters of the universe. Let's back up to the first few 100 million years after the Big Bang. Science tells us that this period was so dim that you couldn't see anything. Space was dark, like someone hadn't turned on the open sign yet. Scientists call this period the Cosmic Dark Ages. For millions of years, the universe was empty. Then a light switched on and everything changed. The universe became transparent, ionized, and filled with light. Scientists have been struggling to understand what happened here. Why an eternity of darkness, then a sudden explosion of light? What happened? Jonathan Tan's new model has a dramatic answer. He believes the first stars to ever form, known as population 3.1 stars, weren't just normal stars. He thinks they were gargantuan beasts, many hundreds of times the mass of the sun, burning hot and fast in the cold soup of early hydrogen gas. Most stars these days are fueled by fusion. However, Tan says the first stars in the universe were fueled by the annihilation of dark matter. And dark matter is even more mysterious than black holes. It's supposedly everywhere, all around us, all the time. Yet scientists have never even confirmed that dark matter exists. And here comes Tan saying that stars feasted on dark matter, turning it into heat and mass until they grew into unstable, monstrous giants. Then, when these impossibly gigantic stars finally collapsed, they went out with a bang heard across the universe. They imploded into the seeds of supermassive black holes, the kind that now lurk in the centers of galaxies like cosmic apex predators. It makes an astounding amount of sense. If true, it would mean that all black holes form pretty much the same way, and it would mean that stars used to be significantly bigger. Supermassive black holes are the relics of the first stage of existence. They are like dinosaur fossils, vestiges of a now extinct primordial universe. A flash before the fall. Tan's theory doesn't just explain the birth of black holes, it also might solve the mystery of early cosmic ionization, that light switch I mentioned earlier. According to his model, these megastars were so luminous, so mind-meltingly bright that they blasted their surroundings with radiation, stripping electrons from hydrogen atoms and ionizing the universe almost instantly. Tan's theory has the universe being this dark, broody place until all of a sudden, all at once, heaps of gigantic stars were born. Their radiation brought light into the darkness. The universe went from pitch black to ultraviolet inferno in the blink of a cosmic eye. What the James Webb Telescope saw. Now, you might be thinking this all sounds like science fiction, but it factually lines up with what astronomers are seeing through the James Webb Space Telescope. This next-gen observatory has been spotting what appear to be fully formed galaxies and possible supermassive black holes in some of the oldest parts of the universe. You know, in your city, you've probably got an old historic district, and then you've got the modern, gentrified areas with cookie-cutter houses next to each other. The universe is kind of the same way. Earth and the Milky Way are in the new, modern section of the universe, but way, way out there, billions of light years away, there are old districts. These older neighborhoods are closer to where the Big Bang theoretically happened. And it's in these old neighborhoods where the James Webb Space Telescope is finding supermassive black holes. Luckily, Tan's model offers a plausible explanation. If population 3.1 stars formed fast, grew faster, and then vanished into black holes, it could explain why the James Webb Space Telescope can't directly see those stars, but rather the aftermath of their destruction. It's spotting galaxies built around the remnants of these stars and the supermassive black holes left in their wake. Richard Ellis, an observational cosmologist from University College London, called it a two-stage process. He said first there was a brief, blinding flash of first-generation stars. This was the lights coming on. The next act was all those stars dying, like the universe's greatest rock band breaking up before they ever recorded an album. Then, from the remnants of all of those superstars, pun intended, came the planets, stars, and normal black holes of today's universe. In the end, Tan's Pop 3.1 idea is still a theory, but it's the kind of theory cosmologists love. It's bold, it's elegant, and most importantly, it stitches together multiple cosmic mysteries with one luminous thread. So, did the first stars set the universe on fire and dive straight into the abyss? Or is this just a dazzling hypothesis waiting for evidence that might never come? Either way, the hunt continues while the cosmos still refuses to give up its greatest secrets. What happens when something gets too close to a black hole? There are bad ideas, and then there's wandering too close to a black hole. It doesn't matter if you're in a spaceship or floating by in an astronaut suit. If you get too close to a cosmic monstrosity like a black hole, you're in for a bad time. What happens? Simple. Physics goes off the rails and your atoms file for divorce. It's like the worst massage in history. You get stretched, squashed, vaporized, slow roasted, and finally swallowed into an abyss that doesn't even pretend to follow the normal rules of reality. So no, getting near a black hole isn't just a bad idea. It's the universe's most efficient delete button. Spaghettification, when physics turns you into pasta. Let's say you're falling feet first into a black hole. First of all, why? But second, congratulations! You're about to experience a little thing physicists call spaghettification. As you approach the black hole, the gravitational pull on your feet becomes dramatically stronger than the pull on your head. Your body stretches out like a noodle, and not in a cute Pixar way. It's more like your atoms are lining up to escape your body one at a time. Stephen Hawking made spaghettification famous in A Brief History of Time, where he described a fictional astronaut getting pulled into spaghetti shape by the gravitational torture chamber that is the event horizon. And it's not just you that suffers this fate. Stars suffer the same indignity. If a star gets too close to a black hole, it can be torn into long streams of gas in an event politely called a tidal disruption. It's like cosmic string cheese, but with thermonuclear plasma. If you get near a black hole, the first thing that happens is you get stretched out like a spaghetti strand. One piece of spaghetti long enough to wrap up the entire planet like a big globular mummy. And then it's pancake time. The pancake of doom. If being stretched into space linguine isn't dramatic enough, a supermassive black hole has a slightly different trick. Instead of simply stretching a star, the immense tidal forces can cause a pancake detonation. The tidal forces compress the person or star from multiple directions, causing them to momentarily resemble a cosmic pancake right before exploding in a fury of nuclear rage. Falling into a supermassive black hole is the absolute worst. One second you're a person, the next you're a pancake. Then you explode in a storm of fireworks as your atoms are ripped apart. Not to worry, things can still get worse. Time dilation. Okay, so you've fallen feet first into a black hole and your legs are stretching away from your head as if you're unspooling a roll of yarn. But from the outside, you'd appear to be frozen in time. Black holes mess with time. Thanks to Einstein's concept of general relativity, the closer you get to a massive object, the slower time moves. That is cold, hard, clock-breaking science. You can even see tiny versions of this on Earth. Did you know that clocks tick slightly faster on airplanes than they do at sea level? Not because they're closer to the nearest black hole, 1,500 light-years away, it's because of gravity. Higher altitude means weaker gravity, which makes clocks tick faster. This effect is minimal here on the planet, but imagine what happens in the event horizon of a black hole. The effect becomes ridiculous. To a distant observer, you'd appear to slow down as you approach the event horizon. Then you'd freeze, suspended in space like a paused Netflix video that will never buffer. That's what people on the outside are seeing. But from your perspective, time is still moving. Your neurons should still be firing in your brain, so you'd be experiencing the passage of time just like you always are. Your heart would be beating normally, or as normally as a heart can beat, falling into a black hole. Your thoughts would be as they always are, and your bodily functions would be fine. People would see you frozen from a distance, but for you, you would slip right into the black hole, no problem. There's this weird misconception that time freezes for people falling into a black hole and that they experience it for pretty much all eternity. But that's only what it looks like from the outside. For the person falling in, the whole thing would be done in a matter of moments. Almost immediately upon breaching the event horizon, you would die. The tidal forces are so strong that you would theoretically be torn apart through spaghettification. But hold on a sec, because let's not forget there are two different types of black holes. Standard black holes mean instant death. You never ever reach the singularity because of spaghettification. But with a supermassive black hole, things are a bit different. Because they are so huge, the tidal forces at the event horizon are not as intense. This means you could theoretically fall into the black hole without going through one of those sausage makers. However, what happens next is a huge unknown. Scientists don't know if a person would make it all the way to the singularity within the supermassive black hole, or what would happen if they reached it. This is a complete unknown, and there's just no answer. Is there a singularity, a wormhole, a portal to another universe, or just a very squished version of whatever fell in? Nobody knows, and maybe nobody will ever know. Any thoughts? When two black holes collide. On November 23, 2023, the cosmos casually reminded everyone that it is a very scary place. Somewhere about 10 billion light-years away, two colossal black holes got into a fight. Each one weighed over 100 times the mass of the Sun. For eons, they circled one another like a pair of celestial dancers locked in a deadly waltz before finally colliding for the grand finale. The result of that collision was the largest black hole merger ever detected, the kind of smash-up so powerful it made space-time wobble. Space-time rippled like a stone was thrown into a pond. It was such a huge event that the ripples from the collision reached Earth 10 billion light-years away. That's absolutely bonkers. Though to be fair, when those ripples did reach our planet, they were smaller than the width of a proton, so thankfully not a crashing tsunami. Still, this battle of black holes resulted in a universe-shaking explosion so violent it bent reality. Humans detected it with instruments so sensitive they could hear the whispers of ghosts. How do you hear a black hole crash? The instrument responsible for detecting this ancient collision is called LIGO, the Laser Interferometer Gravitational Wave Observatory. With twin detectors in Washington and Louisiana, LIGO is a pair of mile-long rulers so sensitive they can tell when space-time stretches and squeezes. At exactly 1:56 p.m. UK time, both detectors twitched in unison. The disturbance lasted 1/10 of a second. What happened in that 1/10 of a second was the ring-down phase. It was the actual sound of the newly joined black holes settling into existence as one giant conjoined twin. And when it settled, it made a ring like a bell being struck. Analysis showed the two black holes were 103 and 137 solar masses, meaning both were already suspiciously large. To put it into perspective, most stellar black holes cap out at around a few dozen solar masses. Anything bigger than 100 is usually thought of as a giant, something so big it shouldn't even exist. Amazingly, both black holes were spinning about 400,000 times faster than Earth rotates, whirling around like galactic fidget spinners pushed to the limits of physics. The best explanation is that these black holes were likely themselves born from earlier black hole mergers. They were still spinning from merging previously when they merged again. And the results weren't just gigantic, they were titanic. The black hole titan. When the dust and space-time settled, all that remained of the collision was a single black hole 265 times the mass of the Sun. For comparison, the previous record holder for biggest black hole clocked in at only 140 suns. This new heavyweight champ more than doubled that, making it a big moment for astrophysicists. Even though scientists have logged around 300 other black hole mergers, this one is the crown jewel. Two black holes collided, space-time rippled, and Earth felt the tiniest shiver. The universe rang like a gong, and humans, armed with instruments sharp enough to hear whispers across billions of light years, stopped to listen. Thanks for watching! What's your favorite fact about black holes? Let me know in the comments below. Remember to subscribe and hit that notification bell so you don't miss the next one. See you tomorrow. Bye!